the board. All right, so as we get started, I'll be introducing here my own presentation. Uh, the goal for this presentation to talk about harbor-based security. How can we harness harbor-based security for our resilient defenses in 2025? So with that, let's go ahead and jump in, and I'll give you a little bit of an introduction about myself. So when it comes to it, I am a SANS Senior Instructor, and I'm also the author of our SEC 401, our Security Essentials class, the class that is designed to give you the essentials that you need to be a well-rounded, capable security professional. Now, more specifically, you might wonder, what does all of that mean, and where do I come from with my experience? So when it comes to it, I have already more than 2 decades of experience helping to develop courseware, being a cybersecurity professional, working in multiple roles and different verticals throughout my career. In fact, I was doing the math this morning, so to speak, and I realized that this would be my 35th year in the field already. 35th year, meaning I actually started back in IT very early on in our early days of cybersecurity. So it's hard to believe I've been around for that length of time already. And what that's allowed me to do is to leverage the various roles I've held over the years into founding two different cybersecurity companies that provide expertise globally around the world. And what that really means to me, what's important to me, is that I have an opportunity to get to meet so many individuals that do so many important things globally, and all of that's a way that we can help to educate and inform each other. Just a little bit more about that then, because this is going to lead into what it is I want to discuss in today's presentation. Uh, when it comes down to it, I'm often asked the question, who should take SEC 401, the Security Essentials class? And it's an interesting answer. The answer is yes. No, Brian, who should take this class? Yes, they should. And it's not meant to be a disingenuous answer, but if you've ever listened to me present before, you know that I like to focus on those yes questions because there's nowhere to go with it, right? Yes, you should. But it's not meant to be disingenuous. What it really means is this. If you are newer to cybersecurity, then it would make sense to take the 401 class, Security Essentials. The goal of the course is to talk about more than 30 different topical areas of cybersecurity, where many of those areas themselves could be their own multi-day class at SANS. We fly high and do deep dives where necessary, but the goal is to allow us to become capable cybersecurity professionals that are incredibly well-rounded. So it makes sense if you're newer to your career, 401 is a great place for you. But what often surprises people, 401 is for everyone. And what I mean of that is of any experience level. One of the things I find fascinating about our industry today is that, well, you can specialize. You can start your journey in cybersecurity with a niche. You can start to focus in one area. And it's easy to spend all of your time in a focus area where you don't know the enormity of what's around you. Say it a little bit differently. This is really one of the only industries I can think of where we do it this way. If you want to be a doctor and you become a surgeon, you become a doctor first and then the surgeon second. You don't just become the specialist in a specific area of surgery before you've become a doctor. You have to learn the enormity of what's around you and then you specialize. And many other industries and fields and professions are the exact same way. And to finally translate that, if you have 2 years, 5 years, or even more years of experience, 401 is still right for you because we want to be capable, well-rounded professionals. And I'll have people who come up to me after class and they say, so that's how that works. Whatever it is that they're talking about. It's how you dot the I's and you cross the T's. Now, I bring this up because it's important for me to be able to share with you where it is that I'm coming from. But what it really means is when it comes to talking about being an instructor for 401, one of the most difficult aspects is that you do have to keep up. I mean, that can be said for anyone in the industry. You want to be in cybersecurity, you do have to have a desire to stay current, and it's not always easy to do. In fact, this is why such a mini day conference like what we're having right now is so important because you can see from all the amazing presentations we've already had in the morning session just how much there is that is ongoing around us and how much all of that needs to be tied together. So with that, then I put together this presentation to talk about one of the areas I've been focusing more of my attention on, especially in the spirit of keeping up, so that I can talk to those important depth levels that is necessary in any conversation, whether it's in class, board of directors, an IT team, right, or in a presentation such as this. It's important for me to be able to stay current. So with that, let's go ahead and discuss what I wanted to bring up here, the focus of the presentation, which is all about hardware-based security. You might have heard terms over the years such as a hardware root of trust. It's important for us to be in hardware before the adversary is in hardware. But what does it really all mean and what does it really boil down to? And I think another interesting aspect, just even as we start to get into the definitions of what it is and what it's not, that's just a highlight of the industry. There's so many ways to describe similar technologies with similar names, but fundamentally are different. And so no matter what we discuss here, and I mean, I only have 25 minutes to discuss it, we always want to make sure that when we ask vendors, when they use a security term, we have to ask them, what does it mean? What do you mean that it means? So we can always be on the same page. But it's also an interesting perspective because when we talk about hardware-based security, we don't discuss it enough. What does it really mean to do hardware-based security? And in fact, to that particular point, um, sorry, I just saw something flash on my screen. It was interesting for a moment there, but I think I'm still presenting okay. Someone I'm sure will let me know. In talking about hardware-based security, the one thing that we really talk about the most is software-based security. And software-based security, of course, is vitally important, especially when you learn that is everything that we do. It is actually all based in software. Or to say it differently, everything we do is software based, whether we're talking about security or not. And even when we talk about hardware, you talk about a CPU, there's no such thing as just pure play hardware doing something. It's running code in some way, shape, or form. CPU has microcode, firmware has code that it executes. So is there even the definition of hardware? But that just leaves us with more questions than anything else. So what's the point and how do we get to it? Well, I think that one thing I'll just bring up right away, hardware-based security is what we need to be doing every step of the way going forward. And if it might have seemed like a luxury or there's too much cost associated with it, those problems are going to have to be solved because of what it affords. The next level in this cat and mouse game where we have defender and the idea of the adversary. Let me explain that one as well. For many years, you've heard comparisons. You've heard things about computers. You've heard about things being more secure than the other. And this is particularly true instead of operating systems. We've heard for years that Windows is more secure, or pardon me, is less secure than macOS, and Linux is more secure than Windows, or whatever comparison. You hear of it on the mobile device side. You hear things like iOS is more secure than Android. And one of the things that's always behooved me, and I like to discuss it over the years, is simple. If something is more secure than something else, why? What does that mean? If you can make a list of differences, then that list of differences can be corrected for. So what's was once upon a time true may no longer be true today, and vice versa. But we often go around making statements that we forget to change our interpretation and to understand where they really came from. You see, if I was just to put this a little more simply now, as we can start to dig in, we talk about Apple devices. Apple, their Mac OS based devices, so traditional clients now. We talk about things like, the tablets and the phones. One of the things that Apple talks about very lovingly is that they control hardware and software. When we hear about the idea that Apple devices might be more secure than something else, it's because Apple has a distinct advantage. When it comes to iOS, it's only designed to run on Apple hardware, Apple iPhones, iPadOS only on their tablets. Well, what about everything else? What about the idea of Windows? Windows is simply software. Microsoft cannot control what you do from a hardware security perspective. What about Android? Android is software. They control the operating system, that is, Google is responsible for Android. They don't control hardware. And what's always been interesting over the years is that Apple has had a distinct advantage of combining hardware and software together. And they talk about it in their keynotes. It's a synergy. And this is what we want to talk about here. So, what is hardware-based security? How does it work? And how has it evolved over the years? Well, I think the one thing that was really ultimately proven incredibly true with these morning's sessions and presentations is that the threat is always dynamically evolving. The adversary is always upping the game, and we have to get to the new targets in the environment before the adversary gets there. When we talk about hardware-based security, we're talking about our security is embedded in the hardware layer before the operating system even starts up. But then how do we get into that? And what does it mean to do hardware-based security? Early on, it might have meant protecting things like the BIOS, the basic input-output system, the chip that provides access to everything else. You turn the computer, identifies the CPU, how many cores, how much RAM you have, your storage devices. It would then look for and locate on the storage devices an operating system kernel and load it. And the BIOS, therefore, or an early example of the technology, you might want to restrict how someone can start an operating system other than the one that's installed. So you might use a password to lock up the BIOS. Well, we've gone a lot further than that way today when it comes to hardware security. So let's go ahead and start to talk about then the ideas of some of the chips here. And of course, we're already well into the presentation. So we've gone from simple password-based protection against the BIOS to evolutions of the BIOS like the UEFI, Unified Extensible Firmware Interface. We've gone and we created TPMs or Trusted Platform Modules, and then we start to tie those into what we call a hardware root of trust. So the best way to describe the idea of a hardware root of trust is to say that all trust starts with our hardware. It's from that point on that every single process that continues in the startup of the system, the following parts of the boot process, can be validated before they're allowed to execute. And this way, if there's any tampering on the system, from the operating system executables to even attempted manipulation of the firmware that runs in our controllers, we might be able to detect it. It could also mean things like we're able to isolate key parts of the computing system away from the operating system itself. To isolate then from the operating system the user space where the user is. And all of this chain of trust that gets built can provide extensive security if we leverage it going forward. So now let's talk about some of the technological innovations that we've seen over the years. Now, for a TPM, a trusted platform module, I'm sure that we've heard of that term before. It's often described in documentation. You hear it as maybe a system requirement for an operating system. A TPM is like a cryptographic processor that might already come pre-installed in your motherboard when it comes to modern computing devices today. Well, what does that mean? Well, a TPM is a cryptographic processor, and one of the things it can generate is public-private key pairs. And public-private key pairs, if you were to take 401 with me, you'd learn that public-private key pairs are a necessary aspect that we should be working with for so many of our security goals. Say it differently, it's the strongest form of authentication that we can leverage in a modern world today. Imagine that we have the ability to use the TPM to cryptographically verify that an operating system executable has not been manipulated. Many of our vendors today will digitally sign their code. Now, if it's digitally signed, they take a hash of it, they encrypt the hash, perhaps with their private key, and one can use the public key to verify that they're executable. The current hash matches the one that's in the signature. That's a powerful hardware root of trust that as the system receives power, the TPM can then be used in conjunction with the UEFI to determine if the operating system executables have not been tampered with. That's the idea of iteration of trust. But today it goes further than that. A TPM might even also leverage our cloud services, where you have what's known as remote attestation. Remote attestation could mean the idea that as the system is starting up, the TPM is already aware of what all of those hashes should look like, including for the firmware of the TPM itself, the firmware of the UEFI, the firmware of any other important hardware devices that are built into the system. All of those hashes can be reported up to your cloud services to do remote attestation. Is this system still in a known baseline of known good, or has something deviated? This could even be assisting you in the idea of potential supply chain attacks. either when the system is potentially being built, I mean, this is not what we're talking about there, but as it's the ongoing ways it's used in your environment, we can tell if a system has deviated, and then that system should no longer be allowed to access our cloud resources or greatly reduce its access within our cloud. But it goes a lot further than that as well. When we talk about the idea that the operating system could be tampered with, a great way to have malware persist on a system, we have something called secure boot. And secure boot is to leverage things like a TPM to again verify the integrity of those executables before they're allowed to execute. Well, that all relates to the idea then of the attestation as well. So you start to tie all those things together. It gives you a powerful way to, at scale, measure any potential deviation in the environment. Because if there's one thing that's true, adversaries need to make changes to achieve their long-term goals. And when you purpose build a system and it's in deployment, it should never deviate under normal operation. And if it does deviate, well, then it should be in your change control log, so you would know that. This is where these things start to tie together. And we already have impressive frameworks that are built to be able to leverage this type of intelligence, leveraging dynamic access control and the beyond. But there's one other thing that comes into play as well. We talk about things like whole disk encryption. Whole disk encryption gets thrown into this mix as well, because when we talk about whole disk encryption, we talk about, well, how are the keys secured? When I talk about cryptographic concepts in 401, one of the things I highlight is that we have a dilemma. A key has to be used by a computer system to encrypt and decrypt for us to be able to access the information that is on that hard disk. But this means a computer knows the key. A key goes in the lock, it locks and unlocks continually. How can a computer know what the key is? It sounds easy. The computer knows the key, but here's the point. Computers, they don't know anything. Computers learn by reading from storage. When a computer is powered off, it doesn't know anything. When your computer is whole disk encrypted and it's in the off state, there's no key in memory. A key has to be actually loaded from the hard drive, loaded into memory, and that key can then decrypt the files. But if the key is on the hard drive and the whole system is stolen, why couldn't the adversary read that key to read the data? And this is where the idea of harbor-based security can come in. The main encryption key that's going to access all the data that's on the hard drive in that system, that key will be encrypted. That's right, it's encrypted before it's stored. And the key that might use that or that's used to do that encryption could be a public key. Whenever you encrypt with a public key, only the private key that matches can decrypt, and that private key is kept in the TPM, in the trusted platform module. So you start to see again here a chain of trust where if everything has integrity and has not been manipulated, we build a more secure startup to our system. And this is something that, again, that Apple has always had a distinct advantage of because they control hardware and software. And what we're starting to see as a deviation then is that hardware-based security is
Claro,
so
está con
important.
este cable,
Everyone
solo que
should
aquí para
have.
atrás.
Oh, I think we have a hot mic situation, perhaps. Ismail? Oh, there we go. Thanks. Okay. Hot mic situation. Um, by leveraging all of these capabilities, I'm sorry, I lost my train of thought there just for a moment. But building that chain of trust, and I was saying that Apple had that distinct advantage. Microsoft and Google both know that all computer users need to have that benefit. And so we're starting to see more hardware integration become important from the operating system perspective. And it was actually, a simple example, something that upset people. But when Windows 11 came out, for the first time ever, Microsoft mandated hardware-based security. You had to have a TPM with specific specifications because all users of all computing systems deserve to have the idea of hardware-based security. Now, I can tell you that it goes so much further than even some of what we've been discussing here. Like, what about leveraging the idea of AI? When it comes to AI, a couple of ways to look at it. It's fascinating. Of course, we can look at AI the way that we've been viewing it, some of the earlier presentations. AI can be a great way to make sense of a large set of data to look for things that are problematic. Like if you integrate it into point of sale systems, you might be able to easily detect the idea of fraud much more easily than a human. And of course, if AI is trained properly, that probabilistic determination of risk can be done very quickly and incredibly well. But another thing that I find absolutely fascinating is that we know that we're going to use AI more and more in our daily lives. And one of the things that we will have to ask about AI is, well, where is it running? Is it running in the cloud or is it running locally on device? Both are going to have their opportunities and both are going to be used. You might run an AI model on device because you don't have access to the cloud more continually, or you're worried about privacy concerns. People are going to want to have AI at their avail. And one of the things that could be fascinating is that hardware-based security might actually be leveraged to protect against attacks against AI. Because if you have models running locally and someone's able to tamper with the weights or the information that it would produce in some way, shape, or form, then one could be manipulated. It could be a different form of social engineering. You might take actions that are consequential to your organization because the data you're working with is now flawed. So you might even leverage AI or pardon me, hardware-based security to be able to determine the integrity of the models that you're running. Oh, and one other thing about that too, right? With AI, it's hard to say exactly where we're going. There's a lot of debate about the safety concerns that come with AI. And what we could also be doing, looking at down the road, is using hardware-based security to prevent AI from running specific functions on a device. So not only the risk that it could be manipulated, but could it be manipulated to cause harm? And can we detect those types of deviations and then stop the system from functioning altogether? We see lots of these use cases in specific industries today. We talk about a TPM being a cryptographic processor, that can store public-private key pairs. Well, banks use even more powerful concepts the same, like HSM or high security modules. This helps to protect the integrity and the confidentiality and authenticity of financial transactions. One of the big area that would be important going forward, what about IoT devices? If there's one area where an IoT device is often problematic, it's in critical industries. And we worry about changes being made. Well, a great way to know that a change hasn't been made is to measure that attestation all the way from hardware all the way up through our software. So as I see more and more industries and perhaps more and more regulations starting to come out, they're going to start to dictate the idea of hardware-based security, which is why we want to be ahead of the curve and understand what it is and how we can leverage it going forward before it becomes a requirement, because it always puts us behind the curve. Now, we talk about how important hardware-based security is, and just even go back to a previous example, talking about how Apple's had a distinct advantage over the years. More and more vendors realize that every computing user requires the idea of hardware-based security. And we even see customized architecture around that idea, like Microsoft Pluton. People say, Pluton, what's Microsoft Pluton? Microsoft Pluton is Microsoft's own development of silicon, working in conjunction with major hardware providers to integrate security features into the CPU. What does that mean for us? When we talk about a secure enclave, you've heard that term, especially when it comes to Apple-based devices. A secure enclave means that in hardware, things are working together within inside of an area that's enclaved. It's sectioned off from the rest of the system, where hardware-based security is protecting more and more of the system's operations. Now, that probably doesn't really help you understand exactly what it is. It's hard to define. So, an example. Okay, going back to the idea of BitLocker. Now, BitLocker holds its encryption on Windows systems. The key is in memory. The key that encrypts and decrypts the files that you're accessing, it's in RAM. And then, even though you had a hardware root of trust, the key is now exposed because the system's operational, it's in memory. You might have heard of things like cold boot attacks or DMA attacks, where you plug in a device, you get access to memory. You might be able to copy out the key. But it might be harder to get to that key if memory is also inside the secure enclave. When we talk about Apple, just to continue that example, Apple Silicon, their new M series of chips that now they've replaced Intel on the traditional desktop systems. The Apple Silicon, their M series chips, almost everything's inside that secure enclave, from the graphical processing unit to the CPU, to the storage controllers, to the encryption keys, to the biometrics. It's unified memory. And if everything's in a more secure area of the system, it makes it much harder for software-based malware to get access to things like those encryption keys. And this is here, we're talking about Microsoft Pluton. This is the idea of Microsoft starting to do the same thing for traditional PC users. Now, it's fascinating to me because, again, people may not have heard of it, but this goes into what Microsoft calls their secured core PCs. And something you want to be looking for in the years going forward, when you purchase a computer and you look for the term secure core, you know that you're starting to benefit from strong hardware-based security that now everyone will have access to. And that's the way that it should be across the board. Now, this is not to say, though, it doesn't come without the idea of challenges. When we talk about hardware-based security and that secure root of trust, what about existing legacy systems that you have in your organization? How do you integrate the two together? Are there cost considerations? Yes, there's always going to be cost. If you could buy a device with security versus one without, right? Would it be cheaper and would that be the decision that's made? In fact, that last part is exactly why Microsoft tried to force the issue with the idea of Windows 11. They required certain things like certain security devices on the motherboard because if there's the option to purchase it without it and there's a lower cost, and of course, when it comes to cost benefit analysis and people don't necessarily understand what it is they're giving up, Microsoft forced that issue. We will start to see more and more regulations, though, that continue on this idea of having a secure hardware base of trust. And Ismail's presentation coming up next, he's going to be talking about zero trust. A lot of these things go into the same bucket of zero trust considerations. So for the future outlooks, because I realize I'm already getting to the end of my own potential of time here, there are going to be some challenges, even beyond what I just discussed. I know I said future outlook, but there's challenges in the future as well. One of the things that will be difficult about hardware-based security is how do you update your hardware? A simple example of that, we're using public-private key pair technologies. What if a private key is compromised? How are we going to upgrade, leverage the ideas of, well, now the private key that relates to the vendor signing, the public key needs to be revoked. How do we get that software update to your TPM or your UEFI without the chance of destroying the computer, right? Breaking the machine. You have a firmware update that goes bad. This computer is completely inoperable. And then what about this? What about quantum computing? So you probably didn't expect me to throw quantum computing into the mix as well, but when we're talking about public-private key pair cryptography, if we're using more traditional algorithms like the RSA algorithm, well, quantum will flip all of that upside down. And while there is the idea of quantum-aware cryptography, well, when are we going to move to it when it comes to hardware-based security, and how will we do the upgrade over time? So we have lots of exciting things that we'll see. But if we leverage hardware-based security in all these devices as they're developed going forward, including IoT, we're going to make it much more difficult for the adversary because we're separating hardware from software. And we want to be in the idea of hardware long before the adversary is. Of course, for the heart industry impact, well, that's a part of the future outlook as well. I'm sure that we'll see specific industries move towards more of these advancements more quickly, but I wouldn't be surprised if we start to see regulatory requirements across the board, across the industry going forward. So that's why I would say that in here, I need to speed it up because I only have a minute left. I'd have to say that in ultimate conclusion, make sure that you are aware what harbor-based security is today. Talk to your organizations about what harbor-based security would look like for you. Understand the potential for upcoming regulatory impact and be ahead of that curve. But at the very bare minimum, operating systems today already support extensive harbor-based security. So leverage it. For example, Google Pixel devices and Samsung mobile devices, they leverage harbor-based security, harbor root of trust all the way up through the Android kernel. We talk about Windows PCs now offering the same type of flexibility that Apple's counterparts have offered. And please don't take it to mean that that was an avocation for or against any specific vendor. When I mentioned Google Pixel and Samsung Knox, those are just two examples of vendors that are making sure they're leveraging harbor-based security. This is something that as consumers, we want to be able to encourage all of our vendors to do across the board because the operating systems already support these ideas. Let's go ahead and move into hardware and let's make it really extra difficult for the adversary. Because in ultimate conclusion, one way I always think about this, a colleague of mine once upon a time to me, she said that she wants an adversary and the adversary's compromise to be worth her time. Now, that doesn't mean that she had ego or anything like that. It meant she was tired of compromises that were too easy. And yes, I know that we do hard work and that she wasn't criticizing anyone in the work that was being done. But when we ignore prudent capability, we're not making it any more difficult for the adversary. We want to make it more expensive and more difficult for them so we can put more pain on their side of the equation. It's not just on ours.